All right, we want to look at some formulas under mechanical energy, all right? But before then, let us define mechanical energy. Now, when we say mechanical energy, we say is the total energy of kinetic energy and potential energy of a body. All right, let us take kinetic energy and potential energy. Now, when we say kinetic energy, we say kinetic energy is the energy possessed by a body in motion. Or we can say that kinetic energy is the energy possessed by a body by virtue of its motion. Now, from this, we can say that kinetic energy is measured in joules, all right? Therefore, mathematically, kinetic energy, all right, kinetic energy, let us use Ke to represent it, is equal to half multiplying the mass of the body, all right, times velocity squared. Okay, so if we have been asked to calculate kinetic energy, we need to know the mass of the body. We also need to know velocity of the body. Then we multiply them, and that will give us what? Kinetic energy. There are some instances where the mass of the body will be given, but velocity will not be given in the question. So we can say that velocity of the body is equal to displacement. All right, displacement, which is d all over what? The time, so t. So we can say v equal to d over what? T. So with velocity equal to displacement over time, or sometimes in the question they can give us distance. So when they give us distance, what can we do? We can use it to replace our displacement and do our calculations with it. All right. So with this, we can conclude by saying that kinetic energy is equal to half multiplying the mass of the body multiplying our distance over time, or squared. All right. So we can arrive at a formula as 1/2, all right, multiplying our mass times d squared all over what? T squared, where we can simplify this formula as Ke equal to md squared all over 2t squared. So we can use this formula to do our calculation for kinetic energy. We can also use this formula to do our calculation for kinetic energy. So anyhow we want it, all these formulas will be applicable. We can be asked to find the mass, you make mass the subject. Find distance, you make distance the subject. Find time, you make time the subject. So these are some few formulas that we can use in kinetic energy in core physics integration. All right, let us look at potential energy. Now, when we say potential energy, we say potential energy is the energy possessed by a body at rest. Or we can say that is the energy possessed by a body by virtue of its position above the ground. Now, potential energy too is measured in joules, all right? Now, mathematically, we say potential energy, all right? Potential energy is equal to the mass of the body, times, that is height of the body, h, times gravity, that is acceleration due to gravity, all right? Acceleration due to gravity. So into bracket G. So we can say potential energy, that is P, all right, is equal to mass of the body times gravity times height. So this is the formula that we can have for potential energy. Here we can be asked to even find our mass of the body. And the mass of the body will be equal to potential energy is equal to gravity times what? Height. And our height will be equal to, that is potential energy all over gravity times mass. So these are some few formulas that we can have under potential energy. We are going to use these formulas to do some calculation in our next video. Thank you.